Okay, the next part of the worksheet is all on half-life and doubling time. So the formula you use for half-life is the population at any given time is the initial population, or the start value. Since it's half-life, your base is 1/2. And then T is the time you're looking at. So after 5 days, how many do you have? After 2, whatever your time period is. And then N is your half-life. So if it tells you that, your half-life is 5 days, then that just means you're going to have N is 5. If your half-life is 3 years, then N is 3. And then your time is in years. Okay? So just to kind of show you how we use that formula, number 4 says you want to calculate the half-life, so which means you want to calculate the N, that is the half-life. Calculate the half-life. It starts at 500,000 milligrams, so that's your start value. After 120 days, so that's going to be your time, it has 122 milligrams remaining. So that's the amount, the population, starting population, and it's 122 milligrams. After 120 days, you're calculating the half-life, the N value. So how do you solve that equation? You have to divide, get that base by itself. So you divide by 500,000. Take the common log of both sides. So it's the common log of this equals the common log of this. And then you use the power property and bring that 120 over N out in front of that log. And that allows you to be able to solve for N. So if the N's down here, most of you decided you wanted to multiply by N. And so when you do that, you get N times all of this. So then you have to take 120 log of 1/2 and then divide by this logarithm. So again, you just type that in your calculator. You get 9.999, which I just rounded to 10 days. All right. Now when they talk about doubling, it's the same formula, except for now your base is 2. Initial population, T is through your time, N is your doubling time. So it's the same formula, except for that's a 2 instead of a base of 1/2. So with this one, what's it say? It doubles every 4 days. So that's your doubling time. Every 4 days it's doubling. How long will it take 1, so that's your initial amount 1, to produce a population of at least 1,000? So you want to know the time it would take to get to 1,000. So the 1 you can just ignore. You can divide by 1, but you can just ignore that then. Take the common log of both sides. So the common log of 1,000 is 3, because that's log base 10. When I take the common log of this, I use the power property, bring the power out in front, so it's T over 4 times the log of 2. So to solve for T, we need to multiply by 4. We need to divide by the log of 2. So I did that. I multiplied by 4 first, and then I divided by the log of 2. I have 39.86, which is 39.9 days. All right, 6. 6 says, a medicine enters the bloodstream, it's absorbed gradually by the body, and the half-life of the concentration is 3 days. So there's my half-life, 3, that's N. If the initial concentration of the medicine is 250, what is the concentration after 30 days? So they give me the time, half-life was 3, initial amount. So this one, all I have to do is I need to plug that in my calculator. I need to figure out what is the population at that point. So I just took 1/2 raised to the 10th power times 250. I got 0.2441, so I said that was 0.24 milligrams. Okay. And then 7 is also a half-life. We have a radionuclide produced, has a half-life of 30.3 years. So that's my N. Now some people thought this 137 had something to do with it. That is just the name of that compound. It really has nothing to do with our formula. So the half-life is 30.3 years. How much must pass for it to be reduced by 10%? So how do you decide what 10% is? Because they didn't give you an initial amount. Well, you can pick an initial amount. I picked 10. So if I pick 10 to start with, it's going to be reduced by 10%, which means I'm now going to have 9, the final amount. So So if it's reduced by 10, I'm keeping 90% of it. So I just picked 9. You could pick 100. You could pick 1. You could pick a starting amount. You just have to make sure this is 90% of that number. My base is a half because it is a half-life. So I'm solving for t. So I divided by 10, took the common log of both sides, used that power property, brought the power out in front. To solve for t, I need to multiply by 30.3, and I need to divide by log of 1/2. So I took this side over here, I multiplied by 30.3, I divided by the log of 1/2. I got 4.61, which would be 4.61 years. You always want to make sure you look at what was your label here. That has to be the same label there. Okay, so for all of the half-life and doubling formulas, you're using this. Your base is either half or 2 if it's doubling time. T is your time, N is that doubling time or half-life. That's what N is, and the initial amount has to go in front. Okay, so that's the all of the ones that have to do with half-life and doubling time.